So Ben, thank you again for hosting me for another day at 3DXR up here in the northeast of England. And Ben is the person that's responsible for my love affair with lithium ion. I'm using lithium ion in some of the endurance builds, particularly in things like long range fixed wing, but also I've started to use it in multirotors as well, where the current capacity is okay. Now, Ben is the person that kind of explained to me about the differences between lithium polymer and also lithium ion batteries. So I'm afraid it's all your fault, Ben. So thank you again for the time this morning. I've had a lot of questions around lithium ion because a lot of people are aware of lithium ion. They bump into it because they've seen it in vapes, and the cells are starting to appear in other things now. So the small versions are in things like the X-Lite radios from FR Sky. So it's starting to become a more common technology. But the cells that you guys are making the packs out of are not the kind of cells that we're buying in the local vape shop, are they? Can you talk a little bit about what the difference is with the cells that you're using between all the ones that I'm kind of getting off eBay?
Yeah, so we use two different types of cell here. One of them has a high capacity, but a lower C rating, and then the other one has a higher C rating and still a very good capacity. So the higher C rating one, we brand these as a power pack, and they can do about 6C constant. They're a 31,000 milliamp hour cell made by Sony, and it's called a VTC6. These are green on the outside. The other cell we have is the high capacity red cell, which is a Panasonic cell in 18650GA. That's a 3,500 milliamp hour cell, and we recommend no more than a 2C constant discharge on that.
Fantastic. Okay, so they are a little bit different from the ones that you'll bump into generally for things like vape machines. What's the difference in the voltage range? Another question I'm getting a lot between the lithium ion packs and the lipo packs, because the one that I've got from you guys, which is I think a 2S3P, which is a kind of a 3S lipo equivalent-ish, the voltages are kind of similar. What's the voltages like in these? And also, what's the workable voltage? A lipo's 3.5 to 4.2.
Okay, so you still charge these up to 4.2 volts a cell, so you can use the lipo charging setting. That's all the same. But in order, where lithium ion battery is different is you can discharge them much lower. So depending on your use, your low voltage failsafe under load could be something like 2.8 to 3 volts. So if you don't actually change the settings on the drone you're putting it in, you might not see the benefit. These need to be run lower. They can be run lower. The dead point is 2.5 volts a cell. Do not go near that.
Right.
So just be cautious of your voltage under load. And yeah, to get the most out of these, what that means is you might actually need to adjust your ESC settings. If you have a low voltage cutoff on your ESCs, it might be that's stopping you from actually realizing the extra capacity of these batteries.
Good to know. Because I first came across these when you were talking to me, and I think it was in a mini Talon I think I was doing at the time, and yes. I was using a great big whacking, I think it was something like a 3,000 milliamp hour battery, and you went, oh no, hang on a minute, you're missing the lithium ion. I used the lithium ion and got kind of like 30-40 minutes flight time without even batting an eyelid or doing anything. Can you talk a little bit about how you use these? Because I've seen them in an awful lot of fixed-wing planes around here, and they're in lots of different shapes, sizes, capacities. You've got big ones, all green ones together, and the green ones again, are they the capacity one? Are they the high
green
capacity?
Ones are the power ones.
Right, so they've got the high C rating,
cell, yeah.
And the red one is the
enduro.
Is kind of enduro, so that the majority of the weight in there is the capacity rather than lots of conductive bits and pieces for the current. So can you talk a little bit about what you're doing with them in planes, because they seem to be everywhere in here?
So we initially start to use these lithium-ion cells just to maximise the endurance of a plane. Basically, you get a 40% increase in endurance. So you can look at that as either I'm able to save weight, or for the same weight of a lithium polymer, I can increase my capacity.
Right.
So in a plane, we would use the enduro packs. The particular plane we use is generally pulling sort of like 1C once it's took off. So it has a bit of a burst on takeoff, and then yeah, we have a plane that'll fly for about 4 hours. The batteries are so good we've never basically been able to flatten it in the air. Crazy, yeah, a massive saving of a LiPo. There's a few other benefits to these which people don't always think. They're actually quite a tough cell. It is a solid casing you're in here, like your traditional sort of AA batteries, although a bit bigger. So they're a little bit more robust when it comes to any sort of harder landings. LiPo packs can be quite prone to having a bit of a knock and split and be a bit more dangerous. So yeah, I'm quite happy with the safety of these as well. So enduro in planes, do be cautious of your takeoff current. Make sure it is within the ratings, and adjust any ESC low voltage cut-off protection you have. So on a plane, I disable that. The power cells, so these green Sony cells, you can go up to about 6C constant discharge. I generally use these in small multi-rotors, so maybe a sort of 450mm, 550mm quad or hex like you've seen around in the pictures. Again, you can't, the lithium ions aren't suitable for every application. If you have a very high current draw multi-rotor, it will be outside the specifications of the batteries. It's not going to work. And the closer you run these to their sort of constant C rating, you do get less capacity out of them.
Right. You're not going to put these on a 5-inch racing quad, is that what you're telling me?
You can, some of them, but you just have to spec it right. So we have put some on racing drones.
You've touched on another thing I think it's worthwhile talking about. These things have a standard discharge that they'll be happy to run at all the time, like you say, like a cruising current in a fixed wing, but they also support burst current as well, and again you'd use that for either quick bursts of increasing your altitude or maybe as part of the takeoff. Can you talk a little bit about how the burst works on this and what you have to be careful of?
So for example, these Enduro ones here that have a sort of 2C constant discharge rating, you could say burst these up to about 6C, which would be your takeoff pull for getting a fixed wing into the air. You don't want to do that at prolonged periods of time. It just won't do it. Also, it's going to increase the temperature. So with any battery, you have to be cautious. Make sure it meets the specification you need. So this will, in the planes we use them in, this will go towards about the sort of 4-5C pull, if you like.
Right, but you'd only do that for what,
yeah.
30 seconds at a time, a minute at a time?
Yeah, 30 seconds.
Okay, all right. So it is literally just enough to get in the air and then start. Okay, cool. So that's how you use it in a fixed wing. What about in multirotors?
So in a multirotor, our 4S2P tube, which you should see in the picture. This is a 4S battery, about 6,200 milliamp hours. And again, there's about a 40% weight saving here over the equivalent LiPo pack. So this particular battery goes in a quadcopter, and again, it's almost given an extra sort of 8 to 10 minutes flight time. So the drone that goes on will fly for about half an hour. That's good. If you look at C rating, if your battery's depleted in half an hour, that's basically, it's been drawn at 2C. This battery will go up to about a 6C discharge. As you approach that, you will find you don't get all the capacity out of it. Like with any battery, the faster you pull it down, the less usable current you get out of it.
Fantastic, because that's what I've done with the one I've got from you guys, which is, because you'll notice on that pack it says 4S2P. Now for those of us who come from a LiPo background, we're used to just talking about 3S and 4S and things like that, but actually what inside this battery, not only have you got things connected in series, which is what we're used to, so this is a 4S pack in this image here, but it's actually a 2P, so you've got also two parallel packs which are giving the ability to supply that additional current. And that's the great thing about these batteries, is that although they have relatively low C ratings when you compare them to high performance LiPo packs, the majority of the weight inside the pack is made up of the stuff that's actually storing the electrical charge rather than great big pieces of metal to carry the big current. But because the capacity of the packs is so big, so this one in this image is 10,500 milliamp hours. You know, a lipo pack of that size is going to be the size of a small house brick. This is a much smaller, denser way of actually getting that out. So even at a 2C discharge rate, that's still 21 amps. Finally, I've got a last question for you. I know you make an awful lot of these, and it was one of the big things that you guys did back in the early days. You know, the batteries were kind of one of the big deals. And I know you still do some blooming big orders for people that have kind of standardized on them for their fixed wing craft. But you were talking about how it's actually not too difficult once you get these high quality cells, once you get your hands on some, to kind of connect them together and make your own packs. But you're talking about a couple of tips, and what were they if you want to have a go at this at home?
Yeah, so first of all, make sure you are getting the genuine cells. There is some little guides online for how to spot which ones are fake. A common thing that unfortunately happens is people get a cheap cell and rewrap them, and you're ending up with a battery that is not what it says it is. So yeah, do find the correct cells to start with. Plan out the layout you're going to do. Make sure you know exactly what's going to be connected where. So our build method at first is we stick the cells together using a black silicon. This is much better than hot glue.
Yeah, hot glue gets
hot glue does
runny again when it gets warm, doesn't it?
It can come off with shock, but also this allows you just to set them up. We make sure they're all straight and square, and then allow them to set. So there's a step. We might leave them overnight just to stick together, and this can be any arrangement. You use a nickel strip to weld them together. I don't recommend soldering the sort of intercell connectors. I use a nickel strip, pure nickel strip, and this could be a 0.1 or 0.15 in the thickness,
right?
8 millimeters wide, and then you need a spot welder to do that. So here we have some.
Okay, I'll put a picture up here of what these little monsters look like.
Yep. Generally, you've got to buy these straight from China. You might see them on eBay. We've gone through quite a few of these.
I love the fact you've
mass
got
battery making
an English one, and you've got with the Chinese characters on the right, so that if you're ever not sure what the right one is, you can translate.
There's more of these in the cupboard that are sort of burnt out, yeah. But we make a lot of these batteries, so they wear out. But yeah, so for the normal person, it's going to last you a long time. Yeah, please, obviously, you are using high current to spot weld these together, so take all the necessary safety precautions. Also, when you're handling a battery that's partially welded, we'll sometimes tape off the top so that you're not shorting anything, and just be very careful until the battery's constructed. We do solder when we put the battery cables on, so we have the balance lead and the positive and negative, so those bits get soldered to the nickel strip, and you generally need to use a flux to get those on to the strip.
To cut through the rubbish.
Yep, and then we might add some form of protection over the cells. So we'll use first a capped on tape, and then either a foam, or for certain ones we 3D print covers and caps. And then the relative heat shrink. So yeah, this example here has had the 3D printed ends on, and then wire protection. Underneath here there is a bit of foam and capped on, so that the
shock protection.
Exactly.
Yeah.
And you get a knife tough one. These are a very popular shape. The one we're showing you here, the 4S2P. These are also the hardest to make.
Of course,
and this particular customer likes them. This one involves a folding in order to get these made. So this is, although they're very attractive and very a good shape for most models, they are a bit slow to make.
Wow. So it does require a little bit of specialised kit, but once you're invested in a spot welder and the nickel strips, and you get the right bits and pieces, it isn't completely beyond the wit of somebody that's pretty good with their hands to put these together.
Yeah.
Thank you, Ben. So I think the way we need to finish this is let me give you an idea of the difference in flight time that you can get in using a lithium ion pack on one of my endurance quads. Let's stick it on the 7-inch quad that we built a while ago, and I'll hand over to myself in the future that's going to talk you through this next bit. So I'm recording this audio after the interview with Ben, so a big thank you to Ben again for putting time aside and explaining all of that to me and allowing me to take all those photographs to show you how it all works. Now, this is the 7-inch quad that we built in the Endurance Quad series. I'll put a link here, and for those of you that remember, we were using a 3700 3S pack and getting about 23.8 minutes, I think it was the maximum time. I was setting my flight timer for about 20 minutes, just to give myself a little bit of extra wiggle room. With the 6240 lithium ion pack on the same model, it's only 3% heavier, but it has 69% more capacity. And because the Endurance quadcopter is built to be as efficient as possible, the current that it's pulling out of the battery is easily handleable by the lithium ion cells. But that additional increase, that's nearly 70% increase in the capacity available to run the system, means that I'm nearly getting 40 minutes flight time out of that model. And that, to me, definitely sounds like endurance. Thanks for watching the video and watching right to the very end. You can find me in all the usual places on social media, and if you like the video and like what I'm doing here, then hit the subscribe button and hit the bell notification icon too. If you really like what I'm doing, you can go the extra mile and become one of my Patreons for access to me directly for support, and also giveaways and regular updates too. If you're looking for particular content, then check out the playlist. I organise all of my videos into playlists, so if you're looking for a particular topic, you can find everything here. If it's called Introduction To, it's designed to start very simply and build on that simple introduction to teach you all about it. If it's called For Beginners, then that is really aimed at people who are brand new to that part of the hobby. You can also search on YouTube for anything that you're interested in using the search function at the top. So iNav Painless 360 will find all of my videos and even the playlist around iNav. So thanks again for watching and happy flying.